This right here, I keep on my desk, I keep in my shop, my wood shop, I keep in my toolboxes. So it kind of travels around. I've owned this now for almost 15 years, okay? It's not special to anybody except me. 15 years ago this summer, my first big project on this campus was to run communication wires from this building, Building D, to every building on campus. So this would be called twisted pair. This is a 100 pair phone line. And then also I ran fiber optic cable. So glass wire, so to speak. So that was my first project. I had just come from the audio company where I was at full time to coming here full time. And I was out on a backhoe digging just right outside the mail room door. I'll never forget this. We had our utilities located, we had our old phone lines located, and so we were replacing the infrastructure. It was a huge project. I was looking forward to it. And one of the scoops with the backhoe came up the end of this cable right here, sticking out of the ground. Not a big deal. Utility company didn't locate it. Must have been an abandoned wire. There's abandoned wires wherever you go, all over the place, in buildings, underground, above ground. And about 45 seconds later, Dr. House comes down his private stairwell, you know, kind of the Holy of Holies area, and he said, "What just happened?" And this is just sticking out of the ground. He said, "You just kicked me off the internet." And we're maybe 6-8 weeks before school's opening up for the semester. And at that point, I had one of those moments like, oh my, I just hit a phone line. And what actually it turned out to be was the main phone line that fed our entire campus. So all of our communications, our networking came through that, and then we had like 16 lines coming in and 8 lines going out, something like that. So our campus was dead just because of this right here. And at that moment, it just kind of froze. I was like, what do I do? How do I do this? I've never worked on phones before. My grandfather, who's dead, was a phone technician for Mountain Bell for many, many, many years. I've done audio. This kind of looks similar, not really. And we had a phone company come out and give us a bid, $4,000 to do a splice that we would abandon in about 8 weeks. And I couldn't justify doing that, so I started thinking, how would I have done this with audio? And we ran temporary phone lines on the ground from Building D all the way to Brown Hall and actually tied our wires, our phone lines and our network lines in all summer long using Cat 5 cable just laying on the ground. The grounds crew had to mow around it. Occasionally they hit it with a mower. We had to replace it. But just by running just temporary cables on the ground that we were going to throw away at the end of the summer, we were able to save $4,000 and get us back going the very next day. If it wouldn't have been for this little bad boy right here, I would have never thought about that. So what I want to try to set the vision for today is there's a lot of stuff we're going to talk about. There's a lot of stuff that may go over your head, and maybe even with this class, a lot of things that you may not realize are like, how am I going to use this? You know, you may not use these things directly, but the principle is going to be there. It's going to be the troubleshooting. It's like, I didn't know anything about telephones, but I knew about audio. I had the tools to trace wires underground, above ground. I had tone generators, inductive tracers that I could use on this. So can I use it on this? Actually, I can, because it's the same, in essence, it's the same wire. And that started getting me to think, so I know this. I need to learn the new wiring diagram for this. I did, and it's like, wow, that's so easy. And then that actually turned up to where I ended up doing most of the wiring on the phone system that summer because my background with this. So when you go out into your ministry, your vocation, you may not be messing with audio all day long, every day. You may do it once a month, once a quarter, whatever. But I hope you'll remember this class. I hope you'll remember this session and realize I don't have to know everything, but at least I know where to start looking. I maybe know who to call or what resources to go to. So this is almost 15 years old in this condition, okay? And I keep it with me just as a reminder of I could have gave up and quit, and we could have spent $4 grand, or I just kind of started figuring things out using the skill set that I have, using my history, using my trades prior to working here. And it actually paid off. And we've done a lot of neat things with this stuff since then because of just experimenting and trying. So that is our scene setter. In cabling, there's a lot of math, there's a lot of science in all of this stuff. And honestly, you don't need to know it, okay? It's already been fleshed out or flushed out, whatever the correct term is. Actually, that's not true. I know that fleshed out and flushed out are not the same thing anymore. I thought fleshed out and flushed out were just kind of a cute little way to say fleshed out, fleshed out. The principle's the same, but you're accomplishing different things in fleshing and flushing. So there's a lot of science, there's a lot of art, there's a lot of history that goes back through this. So a lot of things that we're going to talk about today, you don't need to know when you go to the hardware store, when you go to the music store and you're trying to buy a cable. You don't need to know all the ins and outs. But I just want to give you a little history lesson, just a little different things here and there. Something that makes my head bleed is trying to read this book right here, Sound System Engineering. This was recommended to me about a year ago, so I bought it. And I tell you what, this book makes me want to just quit life. It is that complicated, and there's formulas, and there's math, and it's just like, I didn't sign up for this, but I spent a lot of money on this book, so I've been reading it. But there's something that I read early on, and I've read to our maintenance men about this, and I've used this several different times. But there's a section early on called about craftsmen. Possession of a guitar does not make one a musician, nor do tools make a craftsman. Skill with basic tools manifests itself in clean solder joints, orderly cabling, careful labeling on panels and terminals. Construction of successful loudspeaker arrays is a challenge to both artistry and craftsmanship. In my opinion, experienced craftsmanship is a direct expression of character. So, to make that to where I can understand that a little bit better, just because I hold tools in my hand does not make me a craftsman. Just because I know this information doesn't make me a tradesman or craftsman. It's more to do with knowledge, skill, and character. So that's something that's important to me. I want to be known as a tradesman or a craftsman, and I want to be known as a man of character. I want to be known as, when we call Jude Buffington, Jude's going to provide a solution. He's not going to provide an excuse. So in life, when you men and women go out, it's, why are you the only woman sitting over there? Oh, get it. So when you women and men go out in life, I hope you'll be a tradeswoman, a craftswoman, a craftsman, a tradesman, a man or a woman of character. There's a lot of losers out in life. There's a lot of people that just try to do the status quo and just get by just enough to get paid. We don't need more of those people in life. We need men and women of integrity, of character. So I hope one day we'll be able to kind of join back up again, and we'll both have the reputation of we are people of character. We are people that care about the details. So what does all that have to do with cabling? Well, it has a lot to do with it. Cabling, think about this. This is the medium in which we communicate through. Cabling. So imagine your hallways are your medium on how you travel between classrooms. Those hallways or egresses are extremely important in fire emergencies. If it's dark, if it's smoky, we have to get out of this building really quick. So those cables or those hallways are our raceways, are our chaseways. They're how we move around the building. Cabling is how we move signal. Okay? It can be low voltage signal, it can be high voltage, it can be analog, it can be digital. Cable is how we move signal. So just as important as a fire marshal will put on a hallway or an egress, we need to put the same importance on this stuff because we are moving vital information. And this information is not very powerful. It's low voltage communication. So with the slightest hindrance, we can hamper the communication that's going through here. So if we couple that with our vocation or what we're training for, the ministry, if we believe we have a superior message, well, then that demands superior communication. So we need to make sure that we are providing the people that are going to be communicating with superior equipment. That means we need to know the maintenance of this equipment. We need to know what to buy, what not to buy, what's junk, what's good, and then we also need to know how to maintain it. Our traveling group systems here are full of wires and cabling that is a classic example of people that don't care and don't understand the importance of the cabling. If you understood the communication that was going through this stuff and how sensitive it is, how expensive it is, the art, the science behind all this stuff, it would be treated a lot better. So we need to take care of cabling. One of the things that I do on all my cables is I put rip ties on. These things, they're about 30 bucks for a pack of 10. You can get a couple different rip ties. They can Velcro on. I like the ones that have the zip tie on there so it stays on. When I coil my cables up, I put the rip tie on and it's set. It's ready to go. Another thing that is so important in how you roll your cabling is the over-under method. The audio company that I used to work for is the one that taught me this. This is a common mistake that people make. Go like this, okay? Keep going like this, like this, like this. You'll hear people, audio guys say, don't do that, don't do that, don't do that. Well, why don't we do that? Well, think about this. Every time you do a loop around your arm, you're actually putting a twist in the wire. So when I go like this and go like this, I'm constantly just slowly twisting that wire. Before too long, that wire will start to stretch. When that wire stretches, it gets thinner. When it gets thinner, our communication process starts to break down. Not only that, on wires with multiple conductors, over a period of time, they will lay like a corkscrew. They will not lay flat on the ground. The audio company that I used to work for, he had microphone snakes that were older than me, so from the early 70s. And you pull them out of the box and they lay flat on the ground. But yet here at the school, we have microphone snakes, speaker snakes that are less than 5 years old that are having to be replaced because they're not mechanically wrong. They just constantly twist when you lay them down. They look like a little piggy tail. So he was really big on the over-under. So every time I coil a cable, when I'm coiling it, I'm actually twisting it. So first one's over, second one is under, okay? And I make a loop about that big. Over, under, over, under. When you get the hang of it, it's not a big deal. At the first of it, it looks like you're part of the Special Olympics. It's like, how do I do this? But the point is, okay, that will be edited out. Thank you. The point is, when you pull this out, it will lay flat on the ground. Okay? That's the point of it. Now, the downside to the over-under, and I love doing this just to be annoying to people, because that is a spiritual gift that my mom gave me. If you pull from the wrong way and you start pulling your cable, look what I just did. I just put a knot in every other loop. Okay? So if you're going to be one of the people that does the over-under, you need to make sure that you always pull from the way that you wound it. Okay? So don't pull through. That's why a lot of people get afraid of this stuff, doing the over-under. But that is basic care of your cables. Okay? So when I wind cables, I do over-under. It doesn't matter how small, it doesn't matter how big. I have a speaker snake that's 16 conductors that weighs well over 100 pounds. It's 175 feet long. And if you go to my shop today, pull it out, it's going to be wound over-under. I have extension cords that are that big around. They're bright yellow, and they weigh over a pound a foot. Some of them are almost 200 feet. They're wound over-under. I mean, you're getting biceps when you're doing that. I mean, you lay it on the ground and you're over-under on the ground. But everything that I do is over-under on cabling. So the cabling is how we communicate. That's our mode of transportation with low voltage and high voltage. So we are transporting alternating current. We're transporting direct current or DC, analog, digital. Let's talk about the twist of wires. If you can see this right here, every wire is going to have some sort of twist. Now, this is fascinating stuff. You can see this is a microphone snake. You can see how it's twisted together. But then when we strip back each conductor or each channel, then they're actually twisted in itself as well. What that twist does is that helps with electromagnetic interference, EMI, and then RFI, radio frequency interference, just by that simple twist. Okay, so you're not going to be going out there and saying, I need speaker cable or I need microphone cable with 5 twists per inch or 10 twists per foot. You're not going to be doing that. All that science and math has been done for you. But you need to understand it's twisted. It's twisted for the protection to keep the integrity of the signal. Okay? Low voltage is so easy to disturb. We can disturb it with radio frequencies, so RFI, radio frequencies is AM, FM, cell phone, radar, let's see what else, garage door openers. There's so many FM or frequency modulated frequencies out here that we don't even know about. So AM or FM. EMI is electromagnetic interference that has to do with AC or alternating current from our power supply. So when we're running next to light ballast, when we're running next to outlets or high voltage plugs, that can pick up a hum as well. If you walk by big transformers that are on the ground, you can hear a little buzz in them. You're hearing 60 to 120 cycles a second, so 60 hertz. You're probably not hearing the 60, you're probably hearing the first harmonic, so about 120 of it. So that's so important in helping reduce that stuff is the twist, okay? So all of our stuff is going to have twists in it. Here is a speaker cable. Whoa! You can see the twist in that, okay? This is a speaker cable as well. This is twisted, but it's kind of harder to see because it has a big rubber jacket on it. So all of our cables need to be twisted, which you're going to buy them from the store that way. What does the twist do? This is really fascinating. The more twists per inch, the more high frequencies they're going to reject. The less twists per inch, the more low frequencies they're going to reject. So we've all heard of Cat 3, Cat 5, Cat 5e, Cat 6 cable. All that has to do with is the category 5, it has 5 twists per inch, is all it is. Cat 6, 6 twists per inch. So the twists are really important, and it's not just in audio, it's going to be in high voltage as well. Some of the terms that you may hear in life with cabling is going to be capacitance, inductance, resistance, impedance, EMI, which is the electromagnetic interference, RFI, radio frequency interference. All that stuff you really don't need to know about. You just need to know, hey, is this a microphone cable? Is this a speaker cable? Is this a good quality? Is this a junky quality? The two different cables that we're going to talk about today, we're going to talk about microphone and we're going to talk about speaker. Okay? So we'll start with microphone. Have you discussed fan and power, Joe? Have you discussed balanced and why we do balanced? Do you mind if I discuss a little bit about balance? Okay. One of the things that we talk about in wire is going to be AWG, American Wire Gauge. So this is going to have a gauge. The higher the number of the gauge, the smaller the wire. This is a 22 gauge. This is going to be a 16 gauge. This is going to be a 14 gauge. So you can see the bigger the gauge, the smaller the number. And wire actually goes down to 2, goes down to 0, which is also called aught. Then it goes actually backwards. It goes double aught, triple aught. So that's when you start getting into big wires. So this is going to be the same for when you're wiring your house, when you're trying to get a new plug for your hair dryer, audio, no matter what. It's AWG, American Wire Gauge. So the higher the number is going to be smaller wire size. We're going to use this wire for mic level and line level. Mic level is going to be minus 40 decibels. Line level is going to be minus 10 to plus 4. Minus 10 is going to be more the consumer side. Plus 4 is going to be more on the pro audio side. So this is going to be where we have most of the interference coming from, is this cable right here. It's because the signal is so low. Our speaker level cables, we're not going to have a lot of interference from because that's a pretty strong amplified signal. So let's talk about this in microphone application. Microphone, minus 40 decibels. This would be a balanced cable. We're going to have a plus, a minus, and a shield. A microphone only needs 2 wires. You need a plus and a minus. That's all you need. Or a plus and a ground. Some people call them hot and colds, positive, negative, plus, minus. So this is going to be plus, minus, and a ground. The amazing thing with a balanced cable, and forgive me if I'm repeating some of the stuff. If this is our 0, and then we have plus 5, and we have minus 5, if this is our sine wave, I think everybody understands what that sine wave is going to be. This is going to be our positive, and then this is going to be our ground. So this is how it's communicating. We just need 2 wires, so we need a red, plus, and then the ground. When we're doing a balanced signal, the microphone actually produces a 180-degree out-of-phase signal. So out of phase would be, let's see, so here's 0, here's plus 5, here's minus 5. That's like an upside down backwards 5. That is messed up. So So that's going to be a 180-degree out of phase signal. So our microphone is producing that right there. So then through our cable right here, we have an out of phase and an in phase signal. And then we get back to our mixing console, and it comes back in phase, and then we just have one sine wave once we get back to the mixing console. The beauty about this is this cancels out interference. So think about this. Anytime you have noise that gets into your cable, your noise is always going to be in phase. You're never going to have an out of phase noise or hum or spike. So our noise is always going to be on the plus side of this line. So let's say we have some noise right here that comes into our line right here. Okay? So let's say that is maybe electricity. Okay? On our out of phase, our 180-degree out of phase, we're actually going to have that noise at the same spot, same amplitude. Now, the beauty about this is when we get back to this mixing console, anything that's in phase between your principal and then your 180-degree out of phase, anything that's in phase gets canceled out. So this and this get canceled out once we come back into our mixing console. Our out of phase and our in phase, since they're out of phase, they don't cancel each other out. So that is the beauty about having a balanced signal. Does this make sense? So any interference you're going to have is always going to be on your in phase. It's always going to be on your plus side. You're never going to have it on your minus side. So that's noise. That's noise. Our in phase, our out of phase signal, that gets canceled out right there. So that is the purpose of a balanced cable. You can have balanced cables in mic level, and you can have balanced cables in line level applications. You always want to use a microphone cable and a microphone that's going to be balanced. So some of your cheapy microphones, they're not going to be balanced. But most of the stuff that we're going to do in pro audio, you'll never find a microphone that's not balanced. So we need to have a good balanced cable. This cable will then take the mic level to the mixing console, and then it bumps it up to line level from there. In long runs, this is a major antenna. Okay, this is an antenna. Now years ago, we used to have the recording studio in the music building. And then probably about 16 years ago, we actually brought it over into this old TV studio. Well, we still had the piano in the music building. So I ran overhead, I ran these wires right here overhead from the music building to this building here. So the piano player was in that building, put on headphones, and we had microphones over there, and the singers were in this studio, and all three of us were talking together. We were recording the piano from a whole different building. The singers were singing to that piano. It should have never worked, but it did. When these were hanging through the air, I was so worried about this being an antenna. When we didn't have microphones plugged in on that end, we could actually pick up radio stations through this. When we put microphones in on this on the music building side, that terminated the resistance, and that allowed for our balance signal to start balancing out the RF interference. That should have never worked on paper, but it did. We actually still have those lines, but they actually go underground now because for a couple of years they hung up in the air. It was unsightly, but it was fun. Shouldn't have happened, but it did. So the importance of it is paramount. Not only that, you're going to have a shield around every cable. Some cables are going to have foil shields, which you can't see this foil shield in here. Some cables are going to have braided shields. The braided shields are a lot more flexible, and they're going to hold their position a lot better. The braided shields, they're going to pull out about 90 to 95% of any interference that's going to come into here. Now this is wild. The tighter the braid, the more low frequencies it rejects. Higher frequencies are going to get through the small openings or the holes in the braid, so that's where this is about 90-95% good in RF rejection. This is going to be a foil braid. This is going to block out 100% of the RFI, radio frequency interference, but the foil is not going to be as flexible. So this is going to be for a permanent application, a permanent install. This is going to be where we'd have on a stage or we'd be using portable. In the industry, we call this a soft cord. So these two would be soft, speaker and mic. These two would be for permanent installs. Really the only difference is going to be the big rubber protective jacket on the outside. And that jacket has nothing to do with blocking out junk. It has to do with protection of the cable. And then also on your flexible or your soft cables, your strands are the strands inside here are going to be a little bit thinner, and there's going to be more of them, so they can twist a lot easier. Okay, so this is designed to take the abuse, but it's not going to have the same amount of resistance from EMI or RFI. If you ever have a chance to look online and look at just a frequency chart, you're going to see everything from like 3 hertz, so 3 cycles a second, all the way up to gamma rays, radiation, sun rays. Okay, it's a huge. I think this book might have it. It is phenomenal to try to understand what is out in the air. So it's going to be a chart like this, and you can look at it afterwards. But there's going to be interference from different frequencies. The frequencies that we hear as humans are going to be around 20 to 20,000. Okay, radio frequencies are going to be higher than that. Dogs hear about 18 to 22,000, 24,000, so that's why dog whistles we can't hear, but dogs can. So they're hearing higher. So Abby, the RF interference is going to come at a multiple of different frequencies. So it's not just going to be, we're going to have interference here. Radio stations, TV stations, they broadcast on different frequencies. And then we have cell phone transmissions, we have wireless mic transmissions, wireless network. LEDs give off radio frequency interference. Our power grid is at 60 cycles a second, so that's going to be at 60 hertz. So understanding, and you're not going to pick a cable really that's going to say, I want to reject these frequencies, and you're not going to buy that. But when you're in a church or an application where you're near a radio station or you're having a lot of problems, you may start looking at some more of the specialty cables that are going to be rejecting certain frequencies better. When I worked for the audio company, we were at a church in Moore, and it's right next to KOMA, which was a really strong AM station in town. And we had a long line from the sound booth to back behind the stage where the amp rack was, and we kept getting a radio frequency coming in on that run from the mixing console to the processing equipment. So my boss just finished up a Mountain Dew bottle, and then he took this cable right here, this line level cable, and about 20 times just wrapped it around this bottle. And then he taped it and then put that in the back of the equipment rack, and then from there plugged into the processing equipment. That coil right there is what blocked out the radio frequencies. It created an inductive loop, kind of going along with the same line of in phase, out of phase, going along the same line with twisted wires. He just twisted it up really tight. I think it was about 20 times, and I don't know if there's any math behind that or he just started twisting, but I'll never forget that. We couldn't get rid of the radio frequency bleeding into the line level communication until we did that. So you're gonna get interference of frequencies all over the spectrum. So just for general information, you're not going to have to be worrying about that. Joe's pointing this out to me, and I forgot to talk about, or forgot to get this. This is called Musilux. I'm trying to get rolls of this stuff, but it gets sold out so quick. This is one of the best cables that I've ever worked with. It does not have a metal shield. It has a conductive plastic shield. So there's a black plastic that wraps all the way around it, which is a conductive, and it makes this stuff so soft and so flexible. This stuff's about 65, 70 cents a foot. And as soon as it comes in, it's like thousands and thousands of this feet get sold in minutes. So here's an application where we're not using a foil or a braid. It's a conductive plastic. Different conductor properties that you may use are going to be silver, copper, gold, tin, nickel, steel. Those are different options out there. Most of the stuff that we're going to use is going to be copper, or it's going to be like copper, silver or copper. Silver is going to be the best for communication, but it's also going to be the most expensive. So all this stuff that I have up here is copper. You can also get steel, which steel is a terrible conductor. Steel has, I think copper is 7 times more conductive than steel. But where you use steel is if you have long runs where you need a lot of strength, so you're doing like an aerial run from building to building, it could actually be cladded with a copper or a silver conductor on the outside of it. So we've talked a little bit about braids and shields. Microphonics, that's a term that's used when you have a microphone cable and let's say you're kind of tapping it around and you actually are picking up that thump through your sound system. Microphonics, that's going to be indicative of cheap cables. Okay? So what causes that is, we talked about inductance, capacitance, where we are actually changing the twist or changing the distance between these conductors. Every time we tap it or when we roll it or whatever, we're actually changing the characteristics of the cable. So a good cable is not going to have the microphonics thump as cheap cables would. Let's see here. So moving on to try to get through this with everybody intact. I want to talk about just a couple different connectors that I like, that I use all the time. My favorite brand is going to be Neutrik, and they have a whole line of connectors. Some of the common brands you'll see out there are going to be Canon, Amphenol, Switchcraft, Neutrik. I'll show you the difference between Switchcraft and Neutrik. Switchcraft, that's a classic Switchcraft look right there. Okay, so probably everybody has seen some of these. Old timers call these Canon plugs. It's because James Cannon was the person that introduced this pin style. For years I tried to figure out what XL are, but this is called the Canon plug X, I think in the 40s or 50s. And then they did XL, which is the locking tab. And then XLR, they put a boot on there for, not resistance, but for insulating. So that's how we got the XLR. So XLR. But this has been around from the 40s, 50s. The reason why old timers call them Canon plugs is because James Cannon is the one that made this famous. Neutrik is not an American brand, but they have swept the market over the last 20 years and really have made a superior plug to this. So when I started out in audio, this was the standard for what we used, but now this would be the standard. So this is all I use. Neutrik is going to have a whole line of connections. Neutrik is the one that invented this. This is the Speak-On. Everybody's seen these before. The Speak-On is my favorite connection in pro audio. Here's a plug plate for the minimizers. Everybody should be familiar with that. One of the things that we did on this is I only use this in my audio equipment. You won't see any of these for speaker level applications. I only use Speak-On. But we made a combo. We bought a combo jack here. So that can be either Speak-On or that can either be 1/4 inch. The beauty about this is when these monitors go into churches, most churches are probably going to have this connection for their speakers. But this is really the new standard. Okay, it does not short when you take it out. It is airtight, so you're not going to get air blowing through. So when you're thumping a lot of bass, you can actually hear a whoo, whoo, or it can actually be whistling. And then, I don't know if I said it doesn't short, but then you can have up to 8 conductors through this. So here's my old 8 conductor plug that got busted up. But where this one plug will plug into here, it covers 8 conductors. So 2, 4, 6, 8. So you could look at it as this is a 4-channel plug right here. They make these in 2, 4, and 8. Our speaker snakes here at the college, and then all of my speaker snakes utilize this right here. Again, it's going to be the Speak-On 8 conductor. So we have 4 channels. We have left, right, an aux1, aux2. Now this is an 8 conductor. I told you I have a 16 conductor, so imagine it's a little bit twice the size of this because it's actually a bigger gauge wire. And one of the things I like about this, when you lock it in, you can lock it and it's in. It's not coming out. It's making a solid connection. A lot of people will make the mistake of they'll plug these Speak-Ons in and leave it, and it won't make connection. So no connection is going to be no sound. So it has to have that lock. Not only do we have the Speak-On, but one of the things that I've transitioned to in my plugs, this is going to be PowerCon. This is going to be how I plug all my high voltage or AC power into my equipment racks. Same principle. You're going to have this that locks into, plugs into the connector. twist it in, you just made connection for your high voltage. This will not plug into a speaker jack. That can be detrimental. You're taking a high voltage, an outlet, plugging it straight into your speakers. You could blow up your speakers. I've actually done that before, plugged speakers into outlets. They last for about 2-3 seconds and then they stop working. We actually caught one on fire doing that. It's pretty neat. So anyways, that is our power con, and then speak on right here. So those are available in 2, 4, or 8 conductor. We're all going to be familiar with the 1/4-inch jack. This is one of the oldest jacks that you will see. This is also called the phone plug. The reason why it's called the phone plug is the phone company years ago in the late 1800s made this for the patch panel. I stay away from this. It's the worst mechanical connection out there on the market. But not only that, microphones use this, and then line level applications use this, speaker levels use this. So with where I like to be, this is only speaker level. I try to stay away from this, and then this is either mic level or line level. A cheap way, if you find good extension cords, a cheap way to make a portable speaker cable is an extension cord. So I'll buy extension cords, get them on sale. That's a 14.3. This is a 16.2 extension cord. I just cut the ends off, put these on. This is actual speaker cable right here. Most of the time you're going to spend a lot more money for the actual speaker cables. Hardware stores have sales on extension cords all the time. Just another couple little tidbits while I am letting that solder iron warm up. When we are installing wire, we don't have to get inspections on our installs for audio because it's low voltage. But if I do something that is mechanically wrong or physically wrong, I will fail the electrical inspection. So electricians that are doing high voltage, so lights, outlets, stuff like that, they're going to be on the low voltage contractor because stuff that I do wrong will actually hold up the inspections or make them fail. When we were building the chapel, the electrical contractor was on me because I didn't use enough hangers, J-hangers, to support the wires, and one of the inspectors said these low voltage wires have too much of a sag in them because I didn't use enough of these. I thought I did, but it was the inspector's preference, and so that electrician got all over me and said, you better get these up. We just failed it. You better go, 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 go. Another thing that we need to worry about when we're doing installs is code is going to be, we need to maintain 12 inches between conductors that have a greater than 40 dB signal. So mic level and line level, we're right at that 40 dB threshold. Mic level, speaker level, we're greater than 40. So a lot of the old snakes you'll see in churches and even years ago on the traveling groups here had mic level, line level, and speaker level all in the same snake. That's a no-no now for several reasons. The main reasons is crosstalk. Anytime you have wires that are running parallel with each other, they're going to be able to transmit their signals back and forth. Now the hotter signal is always going to win over the lower signal. That's pretty obvious. If we ever have to cross high voltage or low voltage, we're required to cross at 90 degrees. 90 degrees is we're not going to have those sine waves lining up as if we were parallel. So if we cross, 90. If we're doing permanent installs, we need to maintain 12 inches between mic level and speaker level. Mic level and outlets, speaker level and lights, okay? This will take about 45 seconds to solder on if you're curious about this. So when you solder, getting a soldering iron that's 60 watts, that's what you need to look for. Hotter soldering iron, you're going to melt your plastic. Colder soldering iron, it's going to take a long time to heat up your plastic, and then you can start actually melting the insulation around the wires. The point is we want to get in and get out as quick as possible. A loose mechanical connection is going to be a hot mechanical connection. Hot mechanical connection is going to break down a lot quicker. A cold solder joint is where we actually have an air pocket or an air bubble actually around the conductor, so when we solder it, it actually looks good, but over a short period of time, oxidation is going to occur and we're going to lose that connection. So it's really important that we have good mechanical connections. So when I'm soldering, I get a little bit of solder on the tip. Solder transfers the heat a lot quicker. So what I'm going to do is I'm going to get solder on the wire. Okay, so now I have solder on the tips of the wire. I'm going to trim them down just a little bit because I melted the insulation back, which is okay. And now I'm going to put solder in the soldering pockets on this connection. And I'll pass this around when I'm done so you can see. This is something that a lot of people are afraid of, even your instructor. But this is something I love, and I don't know if it's because people are afraid of it or if it's just there's a challenge. Okay, so I filled those solder pucks, and I'll show you. Okay, so I just touched it, it melted, wire in, dab the wire around, I'm done. Hold it. Okay, solder hardened. So I'm on the middle one now. Just melted. Done. I'm on the third one. A lot of people try to use welders, soldering guns that are like 100 watts. They're going to be way too big and they're going to be way too hot. Okay, so that's it right there.